all levels. Given that R is a 2 by X rectangle, so I'll name this one, this little one R, and I'll make it 2 by X, and R prime, I'll call that one R prime, is a 15 by X plus 1 rectangle. Find all the values of X that make R and R prime similar. So I know I can make those two be the corresponding sides, and then I have to do another set where I have an X by 2, just so that I have all the possibilities, and then 15 by X plus 1 as well. So I'll have one more problem to work on this one. For the first part, I'm going to have 2 and 15 be corresponding, so 2 times some constant will give me 15, and if I divide both sides by 2, then I know that my constant is going to be 15 over 2, or my scale factor. And then I'll have the other two sides be corresponding, so that'll be X times some K equals X plus 1. And since my K is 15 over 2, I'll put that in for the K in the second equation, and so I have 15 over 2 equals X plus 1, and if I rewrite that, that's just 15 halves X equals X plus 1. I want to get the X's to one side, so I'll need to subtract the X from both sides, and 1X is what I have right here, or negative 1X, and that's the same thing as negative 2 over 2, because 2 divided by 2 is 1, so negative 2 over 2X, and I can use that on the left hand side so that I have fractions with a common denominator, and that helps me combine them. So when I do these subtractions, that X minus X there is going to give me 0, and the 15 halves and the negative 2 halves I will have to combine, so it's 15 minus 2 because they're both over 2, and so I get 13 halves X equals 1. 1. And I want to solve for the X, so I need to multiply both sides by the reciprocal, so I'll just flip over the fraction there and multiply by 2 over 13 on both sides, so 2 over 13, and then I can see that my 13s are going to reduce, my 2's are going to reduce, and I'm left with X equals 2/13. So that's one solution. I need to look at the other arrangement where I have an X by 2 so that I'm associating the corresponding sides X and 15 together. So I have XK equals 15 and divide both sides by X because I want to know what the K has to be for this pairing, and I'll have 15 over X. Then I'll associate the other two sides together, make them corresponding sides, so I'll have 2K equals X plus 1, and then 2 times 15 over X, and that's going to be X plus 1, and think of it as 2 over 1, and that'll give me 30 because we multiply the fractions straight across, so 30 over X equals X plus 1. I want to get the X's by themselves, or the X by itself, but I have two of them, and I have one as a denominator, so I want to clear the fractions, which means multiply both sides by that X. So I'll multiply the left hand side by X, and you can think of it as X over 1 for that side, and then multiply the right hand side by X. So when I do that on the left, my X's reduce, and I'm left with 30. Well, I'll still use that color. And on the right, I do have to distribute that X to both of the terms that were there so that everything on the right hand side gets multiplied by X. And then I have 30 equals X squared plus X. And then I want to set it to 0 because I see that I have an X squared and I know I'm going to need to factor. So I'll just subtract 30 from both sides. And these 30s undo one another, and I just have 0 equals X squared plus X minus 30. And then I need to use sum product to figure out my factor pairs, and so I'm looking at the coefficient of the middle term, the X term, and it's a positive 1, so that's what I need for my sum. And then for the product, I look at a product of the lead coefficient, which is a 1, times the negative 30. So I have 1 times negative 30, and that of course gives me a negative 30 for my product and a positive 1 for the sum. And so I'm looking for things that multiply to give me 30. I know I have 1 times 30, there's 2 times 15, 3 times 10, and 4 doesn't work, 5 works, and I have 5 times 6. And now the next number would be 6, but it's already here on my list, so I know that this is the complete list. And if you can figure out the pair that works right away, you don't have to make the complete list, but I certainly want you to know how in case you get stuck and you can't figure out the pair. So you just go up by 1 every time. So start with 1 times that number, and then move up. Does 2 work? Yes. 2 times 15, does 3 work? And so on until you have a complete list. And now I'm thinking I need a negative product and a positive sum. So I want to have my bigger number be the positive so that when I add them, my sum will be positive. So all my smaller numbers on each pair have to be the negative. And I know this isn't going to work because it's a positive 29, but I did get the sign right because my result's positive. And then negative 2 plus 15, that gives me 13. Still not my pair. Negative 3 plus 10, that gives me 7. Not my pair, but I'm getting closer. And then negative 5 plus 6 gives me a positive 1. And so that's the pair I need, negative 5, positive 6. And so I can write this as factor pairs, x minus 5, taking that sign and the number, and then times the quantity x plus 6. And remember, it was set to 0. And this is where we're going to use the zero factor theorem and set each factor to 0. So we have x minus 5 equals 0, x plus 6 equals 0. And then solve each of these little equations. So plus 5, and this one will be minus 6. And we'll do plus 5 on both sides of our little equations. And so this one I immediately get x equals a positive 5 or x equals a negative 6. And I'm thinking, can I really use a negative 6 for a side because I have an x that would be a negative 6? And that won't work. I can't say the side is a length that's a negative number. So I have to disregard that negative 6, and that leaves the positive 5 as my other working solution. So I have x equals, it was 2/13, I think, 2/13 and a positive 5. Those are the two possibilities for the x.